All right, we're good. Please welcome Scott. Well, welcome everybody to January training. Happy New Year. Hope everybody had good holidays and good safe holidays. As you can tell, today we are going to be talking about emergency action plan. It's our annual refresher of what do we do in the event of an emergency here at George Cook Sons. We'll also put in there the fire emergencies and response to those with fire extinguishers and such. So there's lots of different types of emergencies. Here's some pictures of some that when we think about emergencies and we think about the types of things that can happen here. I mean, we really have to do a pretty expanded view of what could happen. In fact, we were just talking before the class about you guys have a fairly significant exposure to railroad tracks and what would happen if a train derailed and the hundreds of different scenarios that could come from that. You can't just say, well, if a train derails, everybody get out of the building, because that might be the worst thing. And so, but the point of an emergency action plan is that we actually take the time to think about those emergencies before they happen, so that we have a less likelihood of panicking when they do happen. And that doesn't mean that at the time of the emergency, as adrenaline starts flowing, that people don't make some crazy decisions. But at least if we give some forethought, there's a little bit of guidance beforehand, and hopefully we can stick to a plan. But we think about fires and weather emergencies, earthquakes, tornadoes, floods, medical emergencies are also part of this. So, just what can happen here and what should be our response if it does happen here. Asking the questions, how would you react if you heard the fire alarm at work? Do you know how to react? Do you know what your responsibilities are if the fire alarm goes off? Is your responsibility to get out of the building and get to the evacuation assembly point? Or do you have some other responsibilities, counting heads or helping the visitors get out, those sort of things? Thinking about these things beforehand. Would you know your role if there was a big chemical leak? What if a weather emergency like an earthquake or tornado? What is your role in that? And I thought this was kind of funny. I included that on here. I think we may need to update our disaster recovery plan. This one suggests that we all run around in circles shouting, "What do we do? What do we do?" And that's a lot of times what happens is we do. If we don't plan ahead, then everybody's looking at each other saying, "What do we do?" And hopefully there's some answers, and somebody will have a cool head because we've thought about some of these things beforehand. First start talking about fires, fire hazards, and fire prevention. One of the chief things that we want to look at when we're dealing with the exposure to fires is flammable liquids and combustible items. Those are all obviously significant sources of fuel. Making sure that we have a plan in place, and we'll talk a little bit about flammable liquids in a minute. Combustible solids. This is something, and I remember this when I first started working with George Cook Sons, and all the team members on the other side of the street hated me when I first got here, because one of the first things I did, Todd, do you remember this? Mm-hmm. I said, you got to start emptying those trash bins. They were full of cardboard boxes and that sort of thing, and so they had to start, instead of emptying them once a day, they had to start emptying them more regularly, and they didn't like that. But I remember having a conversation with everybody, just saying, look, it's just fuel. If there is an emergency, if there is a fire, it's fuel. And it may be the one thing that causes that fire to accelerate so quickly that some people don't get out just because of that fuel. So combustible solids are a big part of it. There's areas in the office area that we have a lot of storage of combustible solids. If the more that we can purge of that, the better off we can be. Machines overheating, electrical malfunctions, another significant cause of fires. Welding and torch cutting obviously is sources of ignition and sources of fires. And then careless smoking habits. And, you know, I know there's no smoking in this building here, but we found evidence of people smoking in rooms between here and manufacturing. You know, we found cigarette butts on the floor. I'm sure most of you have been in that area, and you look at the floors in that area. What are they made of? Dry, old wood. Dry, old wood burns very well, okay? So, you know, smoking, and especially irresponsible smoking, is a source of fires. Going back to the flammable chemicals, one of the things that we have to make sure that we do is that we don't have ignition sources in the area where we either store or are using flammable chemicals. And I would try to keep a 20-foot clearance from any ignition sources. Ignition sources can be things like, if we're using flammable aerosols, an ignition source can be something as simple as a non-rated electrical outlet, or a radio, or a fork truck driving by. And so we got to make sure that we keep 20 foot of clearance away from those operations where we're using flammable chemicals. Making sure that if we're grinding, we might be 20 feet away, but our sparks are going 5 feet close, you know, real close to it. So we have to look at those things and make sure that we're not creating an ignition source. I think it goes without saying, but as soon as I say it goes without saying, guess what? It doesn't. If we're using flammable liquids, we don't want to smoke. We want to store them properly. Make sure that we're locking up our flammables into approved cabinets, which we have approved cabinets out there. So we'll make sure that we're not storing things outside of approved cabinets. We want to understand the labels and the MSDS sheets for, you know, what the hazards are and how to properly store them. Proper dispensing. This is a picture of proper dispensing. It's probably the one thing that I get asked the most questions when I do like an OSHA 10-hour class is when I start talking about bonding and grounding. Okay? And bonding and grounding really is how to properly dispense of a flammable liquid is through a grounded metal container. So you've got a 55-gallon drum on its side, gravity-fed dispensing. You've got a ground wire that may look like electrical conduit, but you can't just hook it to conduit. It has to be connected to an earthen ground. So that is a ground. That pipe there is designed to be the ground for that chemical storage room. So you've got the container grounded, and then what you see here is you've got a little wire lead with alligator clips, and you're dispensing from a metal container into a metal container, and then you're electrically bonding that metal to metal container together so that you can't create a static spark. And it's the same thing when you're at the fueling station, and you shouldn't use plastic gas cans, just for the record, and because you can't get that metal to metal bond. But when you're filling up at the filling station, that tank is in the ground, it's grounded, it's ran through metal piping, so you've got electrical connection to the pump, and then you go to the gas pump, and I realize it looks like you have a rubber hose going from the pump to your car, but there is a wire lead inside of that rubber hose that is electrically bonding that to your car to prevent a static spark. Now, when you hear about people exploding or having fires at gas stations, the static spark isn't coming from the process of dispensing. It's coming from the process of, it's a cold day like today, you put the gas pump in, you go get in your car, you get out of your car and to go shut the gas pump off, and you just build a static spark up on or static load on yourself, and the first place you touch is right there at the gas pump where vapors are coming out. Or right there at the nozzle where vapors are coming out. You get a little spark, and sometimes those vapors ignite. The proper way to do that is not get in your car, but before you touch that pump, is to touch the top of your car or touch the side of the gas pump well away from where it's dispensing, and that will dissipate that static spark and prevent that from happening. So, but that is, when we talk about bonding and grounding, this is a industrial way to bond and ground when you're dispensing flammable liquids. Overloaded electrical systems, frayed or damaged wiring, and defective machinery and power tools all can lead to electrical hazards that create fires. And I don't really think that people understand or appreciate, probably they understand it, they don't appreciate how big of a hazard is overloading circuits. And you know, this picture is designed to be like a really bad picture, but what do you think the chances are that if I go do a little digging today that I can't find this scenario right here? I'll bet any of you a $20 bill that I can. This is an example of an overheated electrical outlet. You know, that could be because it was one of these that was getting overloaded, or it could be because it didn't have it plugged in all the way and it wasn't connected well, and it started doing some arcing, which creates the heat. There's a lot of reasons that could have been overheating, but electrical is a big source of fires, and we need to take that into account when you look at the mess of spaghetti wires underneath your desk. And hopefully none of those spaghetti wires are plugged into space heaters. But housekeeping is a big thing. I just talked a minute ago about fuel and combustible items. Well, most of the time when we have too much of accumulation of stuff, it's combustible items. It's paperwork, it's boxes. But the better job we can do of keeping all that stuff clear and purging that stuff is the less likelihood of a significant fire episode. Obviously, we want to make sure that we keep fire equipment clear. You know, this is a sprinkler riser back here that can't be reached. This is an exit here that's blocked. We want to make sure that we're keeping those types of things free. Then we also worry about natural disasters, things that, you know, are outside of our control. Earthquakes, flooding, tornadoes, those sort of things. And we got to have a plan in place. How are we going to handle these things? And our policies do address, you know, how we handle them. We also have man-made issues like bomb threats, workplace violence, medical emergencies, those types of things. Again, all things that we have to have a plan in place and rely on our policies here at George Cook Sons to how will we handle. When it comes to fighting fires, some of the obvious dangers to fighting a fire are the flames themselves, heat, smoke, toxic vapors. Most people that you know either have serious problems from a fire or die in a fire, they don't die from even the heat or the flame. They die from the smoke and the toxic vapors. They suffocate. So understand that in the event of a fire, those things happen very quick. Has anybody ever seen the video where they've got a fixed camera inside of a room and then they light a couch on fire? And it starts out as this really tiny fire. And in about 30 seconds time, that room is so filled with toxic smoke and heat that you can't even see. I mean, it goes from 0 to 60 and really fast. And so I think that if anybody was ever involved in a fire emergency, you would certainly appreciate at that point how quickly that stuff accelerates. And you know, you might think that starting that campfire is really difficult, but once that campfire gets going in a facility, it really takes off. The firefighting equipment that we have here, portable fire extinguishers that we'll talk about in a second. Fire hose connections, those are used by the fire department when they come out. They can hook their trucks to the side of the building, and that's for their internal fighting. And then fire suppression systems like the paint booth. 4 classifications of fires. There's type A fires that are wood, paper, ordinary combustibles is what they call them. These are the types of things that when they burn, they produce ash. So that's kind of how you can determine a Class A fire. A Class B fire is petroleum-based fires, grease, oil, flammable liquids, paints, that sort of thing. Those are all type B fires. Class C fires are electrical fires, and Class D fires are combustible metals, things like magnesium. And again, I always ask this question, why is it important that we understand a class of a fire?
Just proper extinguisher.
So that we make sure that we understand what the appropriate fire extinguisher is for that fire. And we all know what happens if you put water on a grease fire, right? So in effect, what you're doing when you put water on a grease fire is you're putting a Class A fire extinguisher on a Class B fire. And we know that that's a problem. Well, it's the same type of problem. If I had a Class A fire extinguisher and I have a flammable liquid fire out in the shop and I use that Class A fire extinguisher, it's the same thing as pouring water on my grease fire at home, my stovetop fire. So we have to make sure that we understand those. We do have Class A, B, C fire extinguishers here. Take some of the guesswork out of it, but it's still important to understand those classes. One thing that you can rest assured about fire extinguishers, they all have limitations. And one of the chief limitations is that they don't last very long. You have a very small amount of time where you actually have extinguishing medium coming out of that fire extinguisher. So you have to be efficient with it, but you also have to be smart with it and understand that you're not going to be able to fight a large fire with a fire extinguisher. It's just not going to work. It's not designed for that. It's designed for those, what they call incipient or beginning stage fires, when they're relatively small, and usually kind of a rule of thumb that people use, if it's about a fire about the size of a small trash can burning, then by all means try to put it out. Otherwise, you're probably getting yourself into some trouble by trying to fight something too large. If in doubt, what are we going to err on the side of?
Caution.
Huh?
Caution.
Which means what?
Leave it alone.
Get out of the building. Okay, evacuate the building. We don't want anybody to get hurt. We can replace buildings and materials and equipment. We can't replace people, and so we don't want anyone getting hurt. Get out of the building. We know that when we use a fire extinguisher, we've got to remember the acronym PASS. Pull the pin. Pin's up here in the handle. Pull the pin. Aim at the base of the fire. Squeeze the handle and sweep side to side. Okay? We want to always aim at that base of the fire. Remember, if we're trying to shoot the flames, then we're not going to put the fire out. We have to put the thing that's on fire, we have to be shooting at the base of the fire. And the more time we spend not aiming it in the right location, is the more we emphasize the limitation of not having very much medium inside of it. So we have to be efficient with it. We want to always make sure that we leave an escape route to our back. That don't get yourself into a corner. And again, don't try to fight something that's too large. Chemical spills, understanding the chemicals that we use and how to clean them, how to take care of them, what emergency response is, and where do we need to go to understand what types of emergencies we have with the chemicals that we use. Anybody? MSDS sheet. The MSDS sheet is where we have to look to find what type of response that we need. Sometimes it might just be wipe it up and throw the paper towel away, but sometimes there may be more response. But the only way we know that is to read our MSDS sheet and understand the response for the chemicals that we're using. Sometimes, as I said, maybe evacuating the area is appropriate. We're going to do emergency evacuations for things like fires, gas leaks, chemical spills, and any other thing. And like I mentioned at the beginning of this, things like a train derailment, we can't just say get out of the building. Okay, we can't say that it's an evacuation because maybe it's put a cloud of something that's staying inside is better than going outside. But it might be threatening the building with fire, and the scenario just changed, and now evacuation is appropriate. But there are other things that we may have to evacuate for, other than those three things. We know at George Cook Sons that the evacuation alarm, the notification alarm for a complete evacuation is a continuous alarm, right? That means get out of the building. That means report to your assembly areas. to report an emergency that would necessitate getting a full evacuation, we want to call the safety manager, Roger Shell, at extension 769. Isn't that a 4-digit extension? 9769. Okay. Typo. 9769. Okay. Call Roger Shell. If you're having trouble getting a hold of Roger, then a safety team member. If on a back shift, a safety team member, a supervisor, or a group team leader. But here's the bottom line. We were talking about this before the class. I don't know if you guys remember, but last year we had a lot of questions about this because our policy still talks about switchboard operator, which we don't have. And so it becomes a little bit dicey about how are we going to set off an alarm if there's nobody sitting up there to call to hit the alarm button. Because we all know that the alarm button is out by the receptionist area, right? In the closet behind the receptionist area. So what I would say to you is that we want to make sure that we're getting out of the building safely. That's the main objective, is that we're getting out of the building safely. Get out of the building and then start calling somebody to set off the alarm. And if anybody has any ideas of how we can change our policy that makes more sense and it's more reflective of how we can set that alarm off, I'm all ears and will take suggestions, because it is tough, especially on the other side of the street, when they have to get a hold of somebody over here to activate the alarm. So we probably need to figure that out still a little bit more clearly.
But manufacturers have their own alarms, so they don't have to call over here for it. There's one across the street in the shipping office, plus downstairs has one in panel line.
I don't think I knew that.
They gave you something, write it down. Don't understand, I'll give you.
Let me put that in my small list of things, that nuggets of
They
pearls
don't
of
have to
wisdom Todd
necessarily
shared
call
with
over
me.
here to trigger it for across the street.
Okay. Well, this is something that we need to clarify better, and I will get with Roger today and talk to him about how we can make this more clear. But as of right now, the appropriate procedure is to call Roger and he will activate the alarm or take care of activating the alarm. There's no reason in the world why any of you, if you're having trouble getting a hold of somebody, that you can't call 911 yourself to start getting emergency response for a medical emergency, or the building's burning down, or something just exploded. You know, you guys should all be empowered to call 911 if that is the better route to go, or if you can't get a hold of Roger. So make sure that you do understand that. And I'm going to assume that it's dial 911, right? 911. I think there was just an issue where somebody was in a hotel or something and couldn't get emergency help because they were dialing 911 and weren't dialing to get an outside line. After the evacuation, all team members should report to the assigned assembly areas. For you guys up here, the assigned assembly area is the parking lot, you know, all the way back into the west side of the parking lot. Supervisors are responsible for safe evacuation of any visitors that might be in place, and accounting for team members that are under their supervision. Do not re-enter the building until an all clear signal is, or somebody of authority tells you can do something differently. No smoking until all clear. And I said it before, don't stop and talk on your cell phone. Don't stop and get your car. Go to the assembly area and wait until somebody of authority tells you something different. Understand the evacuation signal and shut down the equipment. This doesn't necessarily apply to you guys up here, but shut down the equipment using emergency stop if it's safe to do so that we're not running out, leaving equipment running that might be a hazard, and then go to this nearest safe exit. Now, seek shelter, different kind of alarm. That was a total evacuation. Now we're going to do an internal evacuation or seek shelter inside the building. This is going to be for things like tornadoes and other severe weather. Again, going back to the train thing, it might be something that we're going to seek shelter because of the emergency created. The seek shelter alarm is an alternating high-low or intermittent alarm. Again, we want to follow the same procedures of call Roger Shell, and he can initiate the alarm. And second choice is getting a hold of a safety team member or group leader and sound the alarm. Report to the designated areas and take cover. Your designated area for the office area is the basement, right? If it's an earthquaker type of thing, we want to take cover, we want to get under something heavy. Again, supervisors perform head counts and make sure that all visitors know where to go to the shelter area. And the maintenance department, when it's safe to do so, they can turn off the gas and water main shutoffs. If it's an earthquake or a tornado, sometimes there's a rupture in gas lines, and so shutting off those gas lines will prevent gas leaks inside the building. And just like the going to the designated areas outside, when we go to a seek shelter, we want to stay in that area until someone tells us to do something different. Earthquakes are kind of a different thing. One is that, you know, they happen very unexpectedly. You know, a tornado, not that we necessarily have warning that we're getting ready to get hit by a tornado, but we at least have warning that there's weather that may produce a tornado, and we can start thinking about it and preparing a little bit. An earthquake just happens. And you may be outside, you may be on the road, you may be inside doing something. And the rule of thumb for an earthquake is if you're outside, stay outside, and if you're inside, remain inside. Okay? If you're outside, look around you. Look at the hazards above you. And understand that, you know, that block wall that once was very solid might be the thing that's coming down on you. So try to get away from things that can fall down on you. And if you're inside, take cover under heavy objects like desks, tables, you know, laying up beside something very substantial might be the thing that keeps a roof from coming in on you. Just a quick summary. First of all, prevention is a preferable thing, okay? Things that we have control over. Things like the fire emergencies, you know, housekeeping, storing our flammable liquids in proper locations, controlling our ignition sources, electrical hazards, you know, making sure that we're not overloading things, making sure we don't have too much plugged into a circuit breaker. Those types of things are controllable things, and if we can prevent an emergency from ever occurring, that's obviously what we want to do. We want to make sure that everybody understands your role in emergency response, and we want to only use the fire extinguishing equipment if we're trained to do so, and if we understand it, and if it's in small incipient stage fires. Know what role you have in evacuation, and you know, I just put this on here. This information, OSHA requires us to do this at home. OSHA requires us to have a contingency plan, emergency action plan. I didn't say at home, I just said at home. OSHA requires us to have it here. Nobody requires us to have it at home. It doesn't make it not safe to, you know, sorry, getting tongue-tied. It doesn't mean that it doesn't make good sense to do it at home, okay? These types of things, thinking about, you know, how am I going to get out of this building? If I got a 2-story house, how am I going to get out if a fire happens in the downstairs and I can't get down the stairs? You know, do I have an emergency escape ladder? Do I have a way to get out of the upstairs? Do my kids know? Do they understand how to get, you know, stop, drop, and roll and crawl to get under the smoke and heat? And, you know, do they understand all that stuff? A real very quick story is that when I was a little kid, my dad was a volunteer fireman, and in the middle of the night, he got called out to a fire. He came home, and he was white as a ghost and visibly upset. And of course, as a kid, you see your dad really upset. You're concerned about that, and he wouldn't tell me what was wrong. And later I found out that the fire that he went to was a friend of mine's house, a kid that was on my baseball team. He was 10 years old. His house caught on fire, and he was so scared, he didn't know what to do. He climbed under his bed. And unfortunately, that was the worst thing he could do, because essentially he was hiding from the firemen, and the firemen couldn't get him out, and he burned up in the fire. And so maybe, just maybe, had his parents taken some time to talk to him about those emergencies and how to handle them and what to do, and that maybe he could have got out of the building. And I'm not trying to be a Debbie Downer here, but that's a reality of what can happen. And preparation, even at home, can maybe save one of our loved ones' lives. So if you don't understand any of your roles under any of this stuff, take the time and ask your supervisor, say, hey, I'm not sure what I'm supposed to do if we get an evacuation alarm. Do I have to count people's heads? What do I need to do? Talk to your supervisor and ask them. I'll open it up real quick for any questions.
Hey Scott, what would you recommend if there were an earthquake happening right now, we're all in this room?
Well, I think that first of all, we probably all want to get away from the walls, get under the heaviest objects we can. We're probably going to evacuate more towards the center of the building. But I mean, you have such little. I mean, when it's happening, you just have to react to at the moment, and we want, like all of you guys, to get away from the wall, maybe get under these desks and provide us a little bit of protection. If it wasn't real bad at the moment and we could walk, if it wasn't that disruptive, then I would get more to the middle of the building. That's one of those things where if it happens, it probably happens and is over before we ever even have time to do a whole lot. Any other questions? If you would, please, if you haven't already, take a moment and answer the questions. And just leave them on the corner of the table over there. And I appreciate your time. And thank you all. And we'll see you next month.
I did the right answer. I just